Long time no see. So today we are going to start with a simple problem. As always, we are going to explain this problem by introduce the example here. So in the input, we are going to have two numbers and a array, right? So the first number tells us how many numbers are going to be in the array, right? So three numbers in the first example. We are going to have three distinct numbers in the array, 1, 2, 3, right? And five numbers in the second example, 1, 2, 3, 4, 5, right? And the second number in the input tells us um, how many subarrays are we going to have. What is a subarray? For example, if we cut here, we are going to have this one and this one, two subarrays, right? And for this example, we are going to have five um, subarrays, right? So we have no choice but to cut at each position, right? We cut four times, and thus we are going to have five subarrays. And when we cut this array into two parts, we can cut this place and also cut in this place. So the way we cut it must satisfy one condition. That is, we need to make sure that the sum of the maximal value of each subarrays must be maximal, right? So if we cut the array here, the maximal value of the first subarray is 2, right? And the maximal of the second subarray is 3. So the sum of the maximals is 5. And that's the first position of cut. And we also can cut it here, right? Then the first subarray's maximal is 2, and the second is 3. So their sum is still 5. So there are two ways of cutting so that their sum would be the maximal, which is 5. So that the first number of the output is the maximal sum, which is 5. And the second number is that how many ways of cutting that can produce the maximus sum, right? So for in this case, two ways of cutting can produce 5, right? And for this example, the only way we can cut it into 5 pieces is that we cut at each place, right? So that the maximal of each sub-array is itself, right? So the sum is 2 plus 1 plus 5 plus 3 plus 4 equals 15. And there is only one way of cutting, right? And as for the last, how are we going to cut this one? So let's introduce the algorithm here. So in order for us to get the maximal sum, we must make sure that the maximum um, value of each subarray must be the biggest numbers of them, right? Because for example, for this third example, that we need to cut the array into 3 subarrays, so that the maximum value of those 3 subarrays must be 7, 6, and 5, right? Because these are the biggest numbers in the array. So we must find the 3 subarrays that each of the subarrays has the maximum value of these 3 numbers, right? How can we ensure of that? So first we can just find the first subarray, right? So can we cut it here? No, because if we cut it here, the first subarray's maximum will be 2. It's not among these 3 numbers, so we can't cut it here, right? So how about we cut it here? Um, yes, we can cut it here. If we cut it here, the first um, the first subarray's maximum will be 7. It's good, right? So we find the first position where we can cut, right? And then let's try the next one, right? Can we cut it here? Yes, right? If we don't cut it here, we can cut it here, right? And if we don't cut it here, we can cut it here, right? And if we don't cut it here, can we cut it here? No. The reason is that if we cut it here, 5 will be uh, removed by 7, right? 7 will be the maximum of this subarray, and 5 will become useless, and the final sum will not has 5 in it, so we cannot um, make this cut as the first cut, right? That's how we solve this problem. So let's say uh, we want to find the possibilities of the first cut. So we can make the first cut here, here, and here. So we have 3 possibilities. And what about the second cut? We can cut it here, here, 2 possibilities, right? And what about the third cut? The only place we can cut the third cut is here, right? So 3 multiplied by 2 multiplied by 1 is the answer, right? So the first answer is really trivial, right? It's just sum up the first k biggest numbers, right? 7 plus 6 plus 5, that is 18, right? So that is the way we solve this problem. So let's look at the code, right? So we have the code here, and here is where we recorded the final answer. I mean the second answer, right? The first answer is quite trivial. We just calculated directly, and we need to actually calculate the second answer, right? So here is where we find the first position to cut, right? So we read all those numbers in x, and if x is bigger than n minus k, that is x. That means x is the uh, biggest biggest ones, right? Um, and start from the first place we can cut. We begin to find the possibilities we can have at the first cut, right? This is the possibilities, right? If we find the first cut here, and also we find that the next biggest numbers is here, then we can find the number of possibilities of the first cut, right? Which is I minus last. And we are going to multiply them, right? Multiply the possibilities. And we find the um, cuts. We iterate through all the cuts, right? And finally, we can output the answer. So I guess that's it for this problem. Hope you enjoy it. So I'm sorry I didn't update very often these days because it's quite busy for me during these days. I work at Amazon, right? There is there are a lot of business during the pandemic. So thank you for the supporting. Have a great day. Take care. As my wife said, take care. Stay at home. Stay safe. Bye.